Hello, Fauxville mathematics students. As you'd be aware by now, I have been seconded to something a bit different for a few days. I'm away on a secret mission. I can't talk about it. I hope to make it back alive, but in my absence, I'd like you to go on with our statistical work. So, yes, second slide you see, you'll be introduced to the term fudging. It's something that's very common in statistical analysis and data handling. Junk in, junk out is another one. So be aware of that as you collect your data for the next assignment. Okay, what we've got is the cross country coming up, and this is a great time for us to whip out a spreadsheet, fire up our calculators and crunch some numbers. So what we can do is collect some data for the Year 7 to 12s, male and female categories. And what we're trying to do is, with our Year 7 to 11 data, make some predictions about what our Year 12s are going to do time-wise. What we're doing is we're going to be using our top 5 results. Basically, we don't want the slow pokes at the back because they could be taken all day. So we want the ones that are actually running, that are doing their best to win the race. We record their times and we record them against their date of birth, and we model it against the month, or their age in months, because there's a big difference between a 13-year-old in 1 month and a 13-year-old and 11 months. This sort of analysis, you know, this is sort of entry level into quant analysis, which is used in finance. And if you want to Google the name James Simons, you'll find that quant finance can be very, very lucrative. Okay, so as I said, we collect the top 5 times for male and female in each year level, 7 to 12. So we enter our data into a spreadsheet for Year 7 to 11. And we create a chart with time on the y-axis, age on the x-axis, and then what I want you to do is experiment with y equals x type, or y equals function of x type functions. There's no right or wrong answer for this. Obviously, to start with, you can do just a basically, a basic linear function, and then you want to look at other things that might fit the data a little bit better, because perhaps the data won't be an exact straight line. So you're looking for something with an asymptote. We've been working with it lately. We're sort of learning the properties of that. It should come together pretty well. Once you've got 3 different functions, then have a look at our data for the Year 12s, their age in months, and plug that into your function and just see how well it corresponded to the time. I want you to do up a brief report, put in your charts, put in your 3 functions, few sentences about the strengths and limitations of your modelling. Look at what your asymptotic value is for time, so our lowest possible time, and just for interest's sake, see if that has any sort of relation to a world record, or any relation to a feasible time, or whether it's something just completely incomprehensible. Like I said, it doesn't really matter. It's just a bit of a play around. It's more about having a bit of a go, having a bit of trial and error, and seeing if you can design something that fits nicely. So to begin with, collect your data, model the linear function. One day after the event, I'll put in a hint sheet on the Google Docs page, on the class Google Docs page. Like I said, I'm not looking for the best formula. Just have a go, tinker around, find something that fits. Brief report, 1 page max. I only want 1 page. Put it up on the Google Docs page by Friday, and good luck.